crack some jokes. The thing is, they can't really hear you. So, yeah. I've had to know that when people ask questions, I need to say it louder so they can hear it. Okay. So we're continuing on here with 11.7. So a full revolution, we talked about going all the way around the circle, or we talked a little bit about radians yesterday, but if we go all the way around a circle, we know that that's 360. We go all the way around a circle, unit circle that has a radius of 1, that would be 2 pi. Using the circumference formula, that's kind of where that comes from. So we have our conversion factor. Now, this is the one that you normally use, the 180 divided by pi, or pi over 180, depending on what it is that you're trying to do. But if you kind of have one of those moments where you're, oh my gosh, I can't remember what it is. You know there's 360 degrees in a circle, and I know that you all know there's 2 pi all the way around. You did that enough in pre-cal that should be ingrained there. So just reduce it, or use it. I mean, it doesn't matter. It's just going to be more reducing for you to do it in your problem if you use the 360 over 2 pi. Okay. So let's do some little conversions here. So 2 pi over 5, let's convert that to degrees. So again, hopefully I'm showing you things that are extremely obvious of what to do. 180 over pi. Now, what if though, well, I'll say that here in a minute. My pi's are going to cancel out. That's what I want to happen. Thinking about like your days back in chemistry, or still in chemistry for some of you maybe. We're going to multiply straight across. My pi's are going to cancel out. I'm going to keep that unit of degrees. Okay, so pi cancels out here, cancels out there. You might even want to kind of what I call cross simplify a little bit with the 5 and the 180. That's up to you. I can also just multiply straight across here. I get 360 over 5, and I get 72 degrees. Now, if you remember yesterday, I told you that sometimes, you know, that measures that have pi in them are obviously radians, but you could have something like 1.2 radians. So how do you convert 1.2 radians to degrees? You would do the exact same thing, okay? Just let me kind of just put this up here just to show you. If I have 1.2 radians, normally there's a pi in that, and the pi is on top. You're still going to multiply it in the same order, but there's no pi to get rid of. So in this case, you would actually have 1.2 times 180 divided by pi, and that would be your degrees. Now you would go ahead and work that out. I don't have a, well, I do have a sign thing here with the pi on it. So that'd be 1.2 times 180 divided by pi. That would actually be 68.8 degrees. Okay, so just because it doesn't have a pi in it doesn't mean you can't convert it, because not all radians have pi's in them. Okay. B, opposite direction. This is a negative degree, doesn't matter, just means that my final answer is going to be negative. So negative 12 degrees times pi over 180. Again, I want the degrees on the bottom so that they'll cancel out. I get negative 12 pi over 180. Make sure you reduce that, okay? And now you'll have, again, a graphing calculator for most of the test, so you can put 12 over 180 in your calculator, switch it back to a fraction, which is a shortcut to factoring or to reducing. But do make sure you know how to reduce a fraction on your own, old school. Divide the top and the bottom by 2, divide the top and bottom by, you know, whatever you can see that they have in common. And sometimes you just have to do it more than once. All right. Sorry about that. So that's L. So I've given you a few of those. I don't remember what it is exactly. I'll show that to you when we get done. You're not doing all of L because I didn't feel like you needed to do that many of those. All right, last part. Okay, back in section 1, we learned about special angles, 30, 60, 30, 45, and 60, that those are ones we had exact values for. Well, now we're doing them in radians, and now we're going to start talking about them in other quadrants. Okay, so this is something we'll do way more with later on in chapter 13, but kind of exposing you to it here a little bit now. Those are all things you should be able to do fairly easily. Now, as far as doing like the 135 and the 120, those are all reference angle angle measures. So like the 120, oops, sorry about that. The 120, you know, that's something that is a special angle because 120 here has a reference angle of 60. So I know 60, so I know 120, because I know about my all students take calculus, so I know that if I do the sine of 60 or the cosine of 60 or the tangent of 60, I know how that's going to change for 120, because it's going to be an angle that's in quadrant 2. Okay. Now, as far as the like 2 pi over 3 and all that kind of stuff, if you need to come up with those angles, it's still reference angles again. The 2 pi over 3, that's a reference angle of pi over 3. So we can do the math there to figure out that that is 2 pi over 3. I don't remember what they do exactly in this section with those other angles. I think honestly it's just kind of like, hey, remember this? And then we do more with it later on. Okay, so if there's something that you see in the homework that I didn't talk about and you don't remember how to do it, as always, make sure that you ask there. Okay, now one thing about the test, I'm not going to tell you, hey, this needs to be in degree mode now. This needs to be in radian mode now. But for the most part, you should know. If they're giving you things that are in degrees, then you need to be in degree mode. If they're giving you things that are in radians, you should be in radian mode. And it depends on what you're doing with it. Okay, this next part of the notes here on some of these, like the very first one, it may not necessarily matter what mode I'm in. It depends on what you're doing. If I'm just taking 5 radians times 2, it doesn't matter if I'm in degree mode. It's only going to matter if you push the sine, cosine, tangent button. And if you're not doing that, it doesn't matter what mode you're in. Okay, so here we go. We're going to find the area of the shaded region to 3 significant figures if theta is equal to 1.2 radians. Okay, any ideas in general how we go about doing that? Cameron.
Find the area of the sector and subtract the area of the triangle.
Exactly. And I'm even going to write that down. We're going to take the area of the sector minus the area of the triangle. Okay, now area of the sector we did yesterday. Area of triangles, we've done that kind of thing as well. One thing there in the directions that they have not put in the picture is that theta is 1.2. So I'm going to go ahead and do that here real quick, 1.2. And then this other side over here is also a 4. So I'm going to stick that in there too, just so I don't end up later trying to figure out how I'm going to get that side. So area of the sector, that formula was going to be 1/2. Actually, let me write the formula in here first. 1/2 theta r squared. And then the area of the triangle, I have side angle side, so I'm going to use 1/2 AB sine of C. Now, we don't have an A and a B and a C, but you get the general idea. I'm going to use that formula for the area of my triangle. Now, that you may not always be able to use that one, but in this case, I have exactly what I need. Okay. So now it's just a matter of plugging everything in. So 1/2, 1.2. My R, that's going to be 4 squared. Now, that part of the question doesn't matter what mode I'm in. I mean, that theta needs to be in radians because that's the formula that's in your formula booklet we talked about yesterday. They're always in radians. But I'm not doing any trig, really. But down here at the end, sorry, I want to put actual numbers here now. That's going to be 4 sine of 1.2. But that 1.2 is in radians because it told me that in the directions. So when I stick that in my calculator, I have to change my mode. Okay, so be careful about that. That's something you may need to do. Okay, so I need to change my mode. And then you can just type that in your calculator all in one step, but just kind of give you an idea, kind of baby stepping it here. This was 9.6. This is approximately that. But again, really, I'd want you to do it in one step. We get 2.14 because it said 3 sig figs square miles. It's kind of an odd unit there, but square miles. Questions about that one? All right, last one. Okay, we have a circle that has a radius of 5 centimeters. We want to find the area of JKL, and then we're going to find theta, and then the length of arc GK. And we're going to give all answers to 3 significant figures. Okay, so couple things here. First of all, I know the radius is 5. I'm going to put a 5 here, a 5 here, 5s all around. Yeah. Anything else that I can label in my picture before we get started? JK, and what's JK? 8.1. Okay, because those formula or those triangles are congruent. Now, if they did not have the arcs in the angles there, you cannot assume that, because it would depend on how much of an angle those radii are. They're not necessarily going to be cutting off the same amount. That's it. That's all we can do for the moment. All right, so I need to find something. I can't find anything right off the bat that they want me to find, so I'm just going to find something. I'm going to use the law of cosine to find this angle right here. And I'm going to call it theta prime just to distinguish it from theta. Okay? Sorry about the pop-ups there. All right, so I'm going to use, again, cosine rule. So 8.1 squared is equal to 5 squared plus 5 squared. Whole bunch more 5s. Cosine of theta prime. Now this question, we have already one angle there that's in radians. So, and actually I guess really okay, we're just going to keep on going because for a minute I'm thinking maybe we could have done, no we couldn't have. I was thinking maybe we could have done this a way easier way, but I was just kidding. We can't. All right. So we're going to solve for theta prime. Now, this is the formula that I use, but in your formula booklet, you do have the formula that's already solved for cosine theta. If you want to use that, that's fine. I kind of like, though, like I said, again, the fact that you know how to do your order of operations here. So when I move the 5s, and I move the 5 squares, and I move the 2 times 25 there, I'm going to end up with negative 0.3122 is equal to the cosine of theta prime. Now, if you were having any issues the other day with the ones where you had to get the angles, it's probably in that solving for cosine theta, so make sure you ask for some help with that. So I do my inverse cosine. I know I'm going to end up with an angle here that is in quadrant 2 because it's a negative. Theta prime is 1.89. Now, you may not even know that that's what that is, but pi over 2, remember, is 90. Anything that's past 90 and between pi, or between 90 and 180 is in quadrant 2. So anything that's between pi over 2 and pi would be quadrant 2. Pi over 2 is 1.57. So that's between 1.57 and 3.14, so it's in quadrant 2, which it should be, again, because I was doing the inverse of a negative. Okay. All right, so I've got 1.89. Well, we've got some congruent angles there, so we know that if one side's 1.89, so is the other. They gave me the 2 radians, so now I've got everything that I need to find theta. I know that all the way around my circle is going to be 2 pi, so I can subtract from 2 pi then to find my theta. So I'm going to go ahead and find that theta first. Well, I guess let's not. The directions really say find the area of JKL, so let's go ahead and do that. We've got my angle now, so we have side angle side. So the area of JKL is going to be 1/2 side times side sine of 1.89. And it's perfectly fine for you just to go ahead and use the rounded 1.89. If you really want to be more exact and you want to use that big long number that's in your calculator, that's fine. The IB exam is not going to expect you to do that, but whatever. My area is 11.9 centimeters squared. Okay, so if we kind of number this there, that would be number 1. Number 2, to find theta, that's going to be, again, 2 pi minus 2 minus 1.89 minus 1.89 will give me theta, and that's going to be 0.503 radians, because it said 3 sig figs. So just like, you know, when you're finding a missing angle in a triangle, you take 180, you subtract all your angles. It's the same thing here, except I'm doing 2 pi instead of 360. All right, last one. We're going to find the length of the arc, GK. Okay, so to find the length of the arc, I need to know the radius, and I need to know the angle measure of that arc, which I know all that now because this is 0.503. Thank you. So we plug all that in. Let's see, 3 here. We're doing the arc. Length is theta times r. So that's going to be 0.503 times 5, 2.52 centimeters. Okay. Now you are going to have some questions on your quiz where you have this kind of, but it's more like part A, part B, part C, where you have to find multiple things. That's something that is very, very common on the IB exam. They like to do, find this, now find this, now find this. And sometimes they're related, sometimes they're not. Like I could have found theta without finding the area of JKL. So if for some reason you can't do the first part, that doesn't mean you can't do the other parts. All right. So let me show you here real quick what you're going to be doing. Or maybe not.
I just finished
All right, so here is L. L, you're doing just A and B for each problem. So I don't, how many problems were there, Jack, for L?
4.
Okay, so you're doing 1, 2, 3, 4, but only A and B for each one of those. And then M, you're going to do all of it.